What is the maximum number of 70 kilogram people that a lift moving upwards with a mass of 400 kilograms can carry safely if the maximum tension in the cable and the magnitude of the acceleration must not exceed 4 meters per second squared? Okay, so in order to do this, you need to draw a force diagram. So basically what we've got a lift full of passengers. So we don't know how many passengers we can take, so we'll just say there are going to be n passengers. Now, it's a good idea in lift problems to draw the lift and the thing that's in the lift separately. So, and we know it's moving upwards with 4 meters per second. So drawing the lift separately, now the forces acting on the lift will be the tension, which is given in the question as 16,200. We've got the mass of the lift, which is the weight of the lift, which is going to be 400 g newtons. And we got the reaction, the combined reaction of all these n passengers, which we'll denote as R. Now, drawing the n passengers separately, we've got their combined weight, which is going to be 70 times n, because we don't know how many, so we've got n times 70 kilogram people times g newtons. And then we've got the force acting upwards, which will be the reaction of them standing on the lift, which we're going to call R, which is the same R as here. Also, both are moving upwards with an acceleration of 4 meters per second squared. So if we just draw those out again quickly, so the same diagram here. So what we've got to do is make an equation of motion for this one and an equation of motion for this one, and maybe then we can solve them. So forming equations of motion using Newton's second law, F is equal to ma. For the lift, we're going to have going upwards 16,200. Going downwards, we're going to have its weight, which is going to, the normal reaction of these people standing on the lift, and the mass of the weight of the lift, which is going to be 400 g, and that's going to be equal to the mass of the lift, which is 400, times the acceleration, which is 4, which is going upwards. Okay, so just simplifying this a little bit, we're going to get 16,200 minus R minus 400 G is equal to 1,600. Now, considering the n passengers, okay, so upwards we got the normal reaction, and then downwards we got the combined weight, which is going to be 70 ng newtons. And that's going to be equal to their combined mass, which is 70n, times the acceleration, which is 4. Okay, having got that, we'll just simplify it. So 70 times 4 is going to be 280n. Okay, we're going to call this equation 1 and this equation 2. And then what we're going to do, we're going to eliminate R by adding the two equations together. So that will give 16,200 minus 400g, the minus r and the r will cancel out, minus 70ng is going to be equal to 1,600 plus 280n. So we've got an equation here, and the only unknown is n, because we know that g is 9.8. So we should be able to find the value of n. So writing it out again, okay, so on this side we're going to have 16,200 minus 400 minus 16,000, and then on the right hand side we're going to have 280n plus 70ng. There's a common factor here of n, which we'll take out. The left-hand side will be the same, and then on the right-hand side we have n times 280 plus 70g. We were trying to find n, so n will be equal to 16,200 minus 400g minus 1,600, all divided by 280 plus 70g. Now, if you put this into your calculator using the fraction button and using 9.8 for g, that will give the n will have to be 11.055, but obviously we can't have 0.055 of a person, so we can say that the maximum number of people the lift can actually carry safely is 11, given those initial conditions for the tension and the acceleration. Okay, this has been a video to show you how to find the maximum people that a lift can carry moving upwards. And I hope you've understood, and I thank you very much for watching.